Hi.
Hi,
Hello.
so welcome to the Global Youth Science and Technology Bowl 2020. Team IAPE 50 is from Macau.
Yeah.
The project title is Interturn Short Circuit Spot Detector for Motor Rotor Winding.
Yeah. All right.
Okay, we'd like to thank you for attending the online judging today and for your efforts made in the past few months. Today, we're happy to have Professor Ho from the Chinese University of Hong Kong, Dr. Rosa Chen from City University of Hong Kong, and Professor Loss from the Hong Kong University of Science and Technology to be judges of the competition. So later you have 5 minutes to present your project. When time is up, we'll stop your presentation. After that, there will be a 4-minute Q&A section. Later, you'll see a timer on my screen. So if you're ready, please tell me and you can start your presentation.
Yeah, I'm ready.
Okay, please start your presentation.
So, dear jury, I'm Huang from Macau. It's my honor to present my invention today. As you know, electric power tools have countless applications in manufacturing, construction, and facility maintenance. When these motors operate under successful conditions, such as repeated start and stop under heavy load of the continuous electrical and thermal stress, it will result in deterioration of winding insulation. And if left undetected early, it may lead to catastrophic motor failures, which will have a significant impact on personal safety and financial investment. When there is a short circuit fault within the windings, the rotor excitation current increases, causing the rotor to heat up. This fault is tough to troubleshoot. The reason is that once the rotor turns short circuit fault between windings, the current will have local fluctuations through the iron core, and the magnetic flux will change. Short circuit identification by instruments such as multimeters is not possible. This is because the wire resistance of a short-circuited rotor is indistinguishable to a functional one. Therefore, we developed a device for detecting short-circuit fault, and it is based on the principle of electromagnetic induction. This device consists of two parts. Number one, an electromagnetic generator that simulates the rotor winding. Number two, the electromagnetic probe of the ferrous metal band is accurately positioned near the rotor winding to be tested. The winding in a turn short circuit fault is inspected by mechanical vibration. Now, I will demonstrate the invention. First, place the rotor to be tested. Local short circuit between the groups of the electromagnetic generator and start the power supply. It can sense that there is a constant electromagnetic field inside the generator. When the current passes through the winding under test, if there is a short circuit fault between turns, the rotor's magnetic flux changes and the electromagnetic field generated by it is volatile. Note the red arrows, which will simulate the direction of the electromagnetic field and the ripple implication with the current. Due to this uneven distribution of the electromagnetic fields between the two, it is easy to produce electromagnets, resonate, and draw conclusions. Second, the rotor under test, normal range, is placed between the groups of the machine. After the power is turned on, there is no indefinite oscillation of the relevant electromagnet. It is easy to obtain the quality assessment of the rotor. Besides, for the marketability and benefits, the invention enables the user to determine the current health status of the electric rotor winding conveniently, quickly, and accurately. It can better ensure the regular operation of the electric motor components, which is more stable and reliable for use from all walks of life or people to use motors. My team has been continuously developing this invention for more than 2 years. In addition, the invention has obtained the International Invention Patent. With the future iteration, we will incorporate a motor quality discrimination device based on audio recognition technology, such as here are some outgoing data you can see. is to replace the process of manual quality inspection. Frankly speaking, we can use a larger EM generator for a higher power to cover a larger area, then use high-resolution electric and magnetic sensors to detect the disturbance with the EM filmed. Finally, I would like to invite you to watch the carefully crafted video demonstration that I have emailed you early. The video will hopefully improve your understanding of my invention. Thank you for your attention.
Okay, thank you.
Thank you.
So, judges, you have any questions for him? So
I'll have one question then. You actually tested, well, I'm watching some of the plots you have included in the report.
Yeah.
You have tested the number of turns at short circuit, right? Does that mean your technique is actually able to identify the extent of short circuit in the coil?
All right.
Am I correct? Let's say if you have a coil that has 1,000 turns, or you can your technique can identify how many turns that there is a short circuit, or the short circuit, the extent of short circuit in the coil.
In some way, this is a proof of concept that can serve a starting point for developing a fault detector for larger motors. So our invention should be very effective because it can also be used in larger motors. Yeah. Also, with this device, we have proven the physics and working principle of using an EM generator for detecting rotor short circuit fault.
Okay. Yeah.
Yeah.
So maybe I have a sort of a question to let's say if I'm a user, all right. So now, like you have this demo that you just present to us like 2 different motors, and you ask us to observe something, right? So let's say if I'm a new user to your system, so what should I look into to identify, you know, let's say there's a problem with the motor. So let's say like because you have a pretty big like setup, right? And I can see that the main thing that you're doing is that you move your like ruler, and there's on the ruler there's some curved like red indicator in some sense. So so let's say I'm a new user. So how will you introduce to me like what should I use, like what should I observe to use your system to identify whether there's an issue in the motor?
Okay, for the operation, my device is made of renewable materials. That means which are environmental friendly materials. So about the operation, you just move the rotor that will be conserved on the materials of my device. Just put it in the groups that, and you can test the short circuit in the turn that it could have or not have.
So maybe can you clarify a little bit what did your demo try to show us then? Like so let's say like in your presentation, so maybe you go through it quite quickly and we maybe missed it.
One point that I want to say, due to large rotors such as those used in power generation are very expensive, and their failures can cause massive safety and cost issues. So my invention should be very effective because it can also used for those large rotors. Yeah. Also, my market research shows that this is a high market demand from environmental concerns where motors components are discarded mainly due to short circuit faults. Being compared with the high maintenance, the cost will be very low, but its performance is superior and the best. This is the main point of my invention.
Okay, so time's up. So thank you for your presentation and explanation.
Thank you.
Your
Bye-bye.
valuable suggestions and comments will be highly appreciated. Thank you.
Okay, thank you.
Bye-bye.
So,
Bye.
we'll let you know the results later on the 3rd of August. So you can leave the, we will ask our colleague to send you back to the waiting room and let your classmate in. Just a second.